code interview problem. There's a graph problem. Oop, I forgot to make an edge there. It's called is a route. I think that's what it's called, but yeah, given a graph and giving two nodes, the function is route or root. I like to say root, and I really wrote that really bad. That takes in two nodes, node one and node two. I'm really drawing really bad. Um, can you see? And you want to check if there's a route between them. So in this case, like you can give a route node 1 and node 5. Then you want to say is 1 connected to 5, or if you traverse the tree, will you get to 1 to 5 or 5 to 1? So in this case, you can see it, which is, yep. Well, how about if you get node 9 and node 4? So you would traverse, starting at 4, you won't get there. Then you can traverse at 9, you won't get there. Maybe we'll start at 2 and 4. You would go to 9. From traversing 2, you do like a breadth first search or a depth first search. Essentially, what I do, you either do a breadth first or depth first search, and for each one from 2 to 4 or 4 to 2, and you tune if there is or not. This one's just a unidirected, but you could also have a bidirectional one, which would work too. So then you can actually get the forward this way. But just in case, the edge case, that it's just unidirected. So yeah, I just thought breadth first search, you just start at each node and you traverse. To do that, so you just have your node class here, standard, has its data, its neighbors, and if it's been visited. And just an add neighbor method that adds neighbors, so when you construct the graph. Yeah, so it's pretty much what it is. So this is kind of like a helper method, just a standard breadth first search. You have your starting node, and then you want to search for a target node. And you just use your queue. The standard, way of doing breadth first search, you have your queue, put the starting node in the queue, and then while you still have a queue, you traverse the neighbors and add to the queue. But if the neighbor that you're looking for is the target node, then you can return true. If it's not, and the neighbor hasn't been visited already, then you can just add or place the node as visited because you visited it, and then add its added to the queue. And if you loop through the whole thing and you don't find your target node, then you just return false. So what it gets to is route is just pretty much a three-liner. You want to first search from n to 1, and if the first search that you did is true, or this returns true or false, then return true. Else you want to do the opposite. You want to go from 2 to, or the second node to the first node. And then if you get to this point, then you just return this if it's true or false. So you can see here, I built this graph here, this 1, 2, 9, this thing right here, right here. So you just build your 9 nodes that we have, and I added the neighbors or the edges. Then you print out, just say, if 2, 2, and 7, if there's a root between them. So can you get 2 to 7? Which return false. So if we run this, we get false. But how about let's try 1 to 7. Let's try 1 to 7. Node 1 to node 7. This should return true. Cool. But yeah, now let's try. This is working, but let's see if we can get to 2 to 7. This should return true, but we have to do we have to add this edge here that we just added. So now 2 points to 1, right? 2 points to 1, node 1. So yep, and that returns true. So but if we take this node out, returns false. The runtime of this is just what's the runtime of breadth first search, twice over. So it'd be n, just be linear for both. So 2n would just be linear. There's also another kind of route you can do a collision that you start a breadth first search at like this node here at 2, and then like, and you do it at the same time, you do it like 6. Actually, that wouldn't work because you don't know if it's unidirectional or not. Because then you just do like you do a wave, you check 1, 9, and 3, and at the same time, then you check 4 and 4, 7, and then from there you do 1 and 2, and then you have a collision here, and then you can return true. But that works with bidirectional with a collision. So that's it. Yeah. So as a route, you just do breadth first search, and yeah, you just start doing 2 breadth first searches, I guess, on the one node N1 to N2 and N2 to N1. And if either of those turn up true, then you're good.